to t. What the value? Gt equal to lambda c to the power t. Put Gt equal to lambda c e to the power t into the our constant equation. Suppose this is asterisk and suppose gray. Now by a and asterisk c will be the value of constant here, limit 0 to 1 and et here, and value of gt is this one. So we can write lambda c e to the power t into dt. It is clear? Clear?
Yes, sir. Hello.
Hello.
Hello, sir.
Hello, sir.
Hello. Hello. Uh, wait, wait. Now, am I audible now?
Yes, sir.
Yes, sir.
Okay, okay, okay. Yes. So here we 2c upon e square minus 1 is a constant. So we can say g equal to e to the power t is the eigenfunction and lambda equal to 2 minus 1 is the value corresponding to this integral equation. I'm repeating again the procedure. Suppose integral equation, and first of all you identify the integral, which type of that integral equation is. So in this integral equation, its limits are finite number, so it is fixed. Limit are fixed, so it is random integral equation. We will see if kernel is separable or not. Now we can see this is the kernel. This is the kernel, and in this kernel, this kernel is separable from means e to the power s and e to the power t. So first of all, we will discuss if the Prandtl integral equation with second kind. Second kind because coefficient is one here. Okay, and here the function of f is zero. It is homogeneous also. Okay, homogeneous and second kind. So here it is a separable kernel. So you can see that in the integral from limit are from 0 to 1 e to the power s, e to the power s, e to the power t, gt, and okay. So because function uh, kernel separable form, so we can the function of s here. Okay, because its limit is from 0 to here t lies in the integral from 0 to 1, and this is the function, and we have integral from this quantity with respect to t here. So it means that will be, we can assign it is a constant. So we, okay, and now you can see that this quantity is constant because its limits are fixed. So it means that this constant. So we can assume this quantity is c. Okay, so if we write this integral means this quantity is c, so we can write gs hello, any doubt in this example?
No, sir.
Okay, may I continue? Yes. So this is the process. Process is, first of all, you have to identify the integral equation. Means that integral equation is in a separable form or not separable form. Okay. Again, I take the Frendelov integral equation with separable kernel also when the equation is okay. Now, integral equation with separable kernel, okay, but non homogeneous. Homogeneous case. Homogeneous case. Okay. So first of all, I will discuss this with the help of an example. Okay. Suppose first I take one example here. Ux is equal to e to the power lambda. Okay, so e to the power x plus lambda limit from 0 to 1 again, twice of e to the power x and e to the power t, and also it is ut and dt here. Okay, now you can see that you can see that this is its coefficient is 1 here. Clear? Its coefficient is 1 here, so it means that this equation is second kind, and here fx is not equal to 0. It means that it is non-homogeneous, and also you can see limits are fixed. It means it is a Frendelov integral equation. Here u is the unknown function. Clear? It is clear about the equation. Now we have to find eigenvalue problem, or also eigenvalue problem means we have to find eigenfunction. Eigenfunction is nothing. We have to find u, and u is nothing. It is the solution of integral equation. Am I right? Okay. So what will we do? We will see first. It is the kernel here to the power x and e to the power t. Here you can see here k comma x comma t is equal to twice of e to the power x and e to the power t, and you can see it is a function of x here, it is the function of t here. So it means that we can write it is hx and we can write it is gt. So it means that this kernel is in the separable form. Do you agree this? Okay. Now again, so what we do? We will write again this equation into like this way: ux is equal to e to the power x plus lambda, because we are taking the integral with respect to t. So e to the power x we can assume as a constant. We can take outside of the integral. Then we can write it twice e to the power x is like this way, from 0 to 1, e to the power t and ut and dt. And again, now you can see its limit is fixed, so this quantity is constant. So we can assume that it is c here from limit 0 to 1, e to the power t here ut into dt. It is clear here?
Yes, sir.
Okay. Okay. Now, so function will be here, ux will be limit e to the power x plus twice lambda e to the power x into c. I have substitute, so I can write this equation 1, this equation 2, and suppose ux is equal to e to the power x plus twice c lambda e to the power x. This equation is 3, and also I can write here ut is equal to e to the power t. I can take a common 1 plus twice c lambda. I can write this as prime. It is clear from here? Till now, is any problem? Till here, is any?
No, no, sir.
Okay. So now we will substitute the value of ut into the our constant term. Then what will be? Means from 2 and 3 prime. C will be here limit 0 to 1 e to the power t into e to the power t and 1 plus twice c lambda and into dt. Clear? And now you can see that this is the constant, c is equal to, this is the constant, so we can take outside of the integral 1 plus twice c lambda integrating from 0 to 1 e to the power 2t into dt. Am I right? Now taking the integral, we will obtain c is equal to 1 plus twice c lambda, and it is e to the power 2t limit from 0 to 1, and we will obtain here c is equal to 1 plus twice c lambda, and it will be here e2 minus 1, and from this expression we calculate c is equal to, because c is here and c is here, take the outside of the c and arranging the terms, we will obtain c is equal to e square minus 1 upon twice of 1 minus lambda e is 1. Okay, condition is that means lambda is not equal to which quantity? 1 upon e square minus 1. Okay, if this quantity is equal to 0, then c will be 0. Okay, sorry, c will be infinite. Okay, so c is not infinite. Okay, because we are taking any scalar. Any scalar means it is a finite number. Okay, we obtain the value of c. Now substitute the value of c into the our eigenfunction ut and over ux, then we will obtain ux is equal to, just I can write the expression after solving, we will obtain here only ex upon 1 minus lambda e square minus 1. Okay, and also we can write quantity, so we can say that e to the power x is the eigenfunction of Fredholm integral equation. Which is the required solution. Okay, and substituting ux, okay, so this quantity c will be equal to, we obtain the value of c here. Okay, now so you can also substitute the value of c in the this. Okay, just it is the solution, and lambda must not be equal to 1 upon e square minus 1. Every lambda is the fourth value of lambda, if not equal to this quantity, will be the eigenvalue. Okay, so this is the procedure. Any doubt? Here, any doubt?
No, sir.
Okay. Now, this is the case. Okay. Now, assignment to you. Find the eigenvalues. Also, we can say that eigenfunction means if you are finding the eigenfunction, it means that it is a solution of a integral equation. Okay. Okay. Assignment for you. Suppose phi x is equal to lambda limit 0 to pi and k comma x comma t and phi t in dt dt. Okay, this is the question, and solve this equation, solve integral equation, or also you can say find the solution of this integral equation. Also, you can find the eigenvalues and eigenfunction of this integral equation. Okay, and where k comma xt is equal to it is cos x sin t when x lie between 0 to t, and cos t sin x when t lie between 0 to pi. Here pi. Okay, so find eigen values and eigen vector. Eigen function also called, we will call eigen function of this integral equation. Okay. Now you can see that here kxt is a kernel, and kernel is in this form and this form. In this case, it is a function of x only, it is the function of. Also, you can see it is a function of t only, it is the function of x only. So it means that the kernel is in the separable form. Okay. Try to show this. Okay, so tomorrow we will start again Frendelum integral equation, non-homogeneous Frendelum integral equation of second kinds, and by the Hilbert-Smith theorem. Okay. Now, please wait. I am making the attendance. Then after you can. How many students? Only 20 students are here. Where are other students?